Yeah, so my name is Benjamin, and I've been participating now in since we did the calibration network. Did a lot of experimenting with the mining setups, and now I also kind of presented it already during the space race. So we figured out that, why not spend some more time on actually going into this kind of solo mining setups. So one of the things that I also said last time was that I'm using an unmodified Lotus version, meaning that I generally don't go in and modify, optimize, or do any hacks to Lotus. So I kind of have to work with the software how it is. So how I do that is more like trying to make the hardware fit and trying to make that work as good as possible. So last time I you saw some pictures of some of the equipment during Space Race 1, which was basically just taking a lot of hardware and trying to stack it up and see how much storage we could get on there. I'm going to show you some more pictures of what it looks like today, because obviously it's not like this. But the general idea for what we're going to talk about today is the sizing. So now you see the rig here with some different computers, and the general problem when coming to being a solo miner is that when you have quite small mining setups, you really need to have a focus on how do you balance the mining setup. So that's really important. Now, I also did some experiences doing Space Race 1 and doing some more experiments doing Space Race 2. But basically it comes down to now that I kind of try to lay out what are the different ways of doing this with quite small setups. So so this is so far what I've been working on. Basically what you see here is a list of different setups, coming from having a single rig and into having a kind of, you can't really call these big mining setups because these are not data center size. So no matter what, they're not really that big. But anyway, this is kind of trying to say what could it look like when you are dealing with smaller size computer clusters. So I grayed out some of them, and that's basically because I have not tried them by myself. So the community here on Slack is very strong. You can get a lot of help on how to set this up in all different kind of ways. I've only personally experienced with some of these, and it's not everything that is really feasible to actually do, although that it might work. So what I try to do is basically just put it up here saying that, for a single rig, you will only have a single computer, which is a miner. Then you can add on workers to that. And what roles would you have those workers to do? So, so basically you start from just having a single computer, and then to having, in the biggest setup here, I had 9 when this happened. So from that, I also tried to do something down here in the bottom where we have some performance measures. So one measure that I use is in general how many. So I guess most of us are running 32 gigabyte blocks at the moment. So that's what I measure everything in. But basically, you have an idea about how many blocks would you be able to do every day. So that's one thing. The other thing that I use very much is what I called my balancing metric. And that's basically how I calculate everything. And I would really like, if we could get out of this session today, and you also had this idea about this kind of metric, which is basically how long time does it take between I can pledge a new sector. So for these systems you see down here in the bottom, we have a lot of them saying around 2 hours. So how I would interpret that is like, so every second hour I would be able to pledge a new sector, or pack a sector with deals in. It doesn't really matter. It's much more of saying how much capacity is there in here. So the reason why this is important about how many hours between or how many minutes between I can pledge a new sector is because you can actually use that metric for each of the workers. So for each of the jobs that they have to do. So basically, if I need a rig like this that can do a new sector every 2 hours, then I would need a PC1 worker, which can produce a new sector every second hour. But it would be the same for my PC2 and for my C1, C2 worker. So basically, I can apply this to all of them. And coming up here in the end, which is the biggest setup that I did, which I was using here on Space Race 2, I got it down to about pledging a sector every 24 minutes. And basically, for me to figure out, what is this number? Well, one thing is I can figure out how many PC1 processes can I run in parallel. So how much can I get through there? So that's one thing. But then I also need to make sure that I got enough PC2 workers to actually handle that workload. And then also the C2 workers to actually finalize and get it, out of the way, because otherwise I will get congestion somewhere in here. So just taking back to what this says is that you can have a single miner doing everything on the box. You can have a split where you say that you have one being the miner, and then you can have a worker actually doing all the sealing. That would be the basics of having, a separate sealing worker, and then having your miner just doing the operations of proving the storage and so on. So that's also a way to do it. But I haven't tried any of these solutions, and I generally did not try with anything simple. I just went for the cluster directly. So the minimal setup that I have running right now is that I am only using three servers now. So I have my miner, which runs the daemon and the ant miner process, and it actually has a pretty good GPU. But that was just the intention of making sure that I would be able to win new blocks and not having a miner that's slow that it would actually not be able to mine. So that's one thing. Then I have a fairly little PC1 worker, which is nothing special. It does have some memory and it has an epic CPU, but apart from that, nothing really special about it. The reason why I'm holding a little bit back is also because we all know that there are optimizations going on, meaning that, if we get a new version of Lotus where we now have, the new features and the optimized PC1, then we might have double speed on PC1. So now I might end up having a PC1 worker, which is actually producing the double amount of sectors per hour, time between every sector get the half. So then I need to balance the rest of it. And then it might be next month that we also have optimizations going on for PC2 and for C2. And that's why it's really important to understand these metrics, because every time something like that happens, so something gets double speed, meaning that you can pledge now the double, well, then the rest of it needs to rebalance to actually make it work. So I'm not sure that we're going to see that the improvements is going to be for PC1, PC2, and C2 at the exact same time. So that's to take into consideration. But this is actually the setup that I'm running now with the 3 servers. Then we have another setup where you could actually you could split it in another way. So right now I have a separate PC1, and then I have another worker which just do the PC2 and C2, which basically in this setup just needs to spend about, if it can do that within 2 hours, then it's all good. So both processes within 2 hours, because my PC1 worker would only spit out a new sector every second hour. So, that would work. But another way to do it is actually to say that, you might have your PC1 and PC2 on the same machine, and you can actually do that with the new Lotus. But the problem could also be that if you do this, then your PC1 gets really slow because PC2 is taking up some of the CPU resources. But in general, this could be a good idea because you would use the PC2, which does not use much memory, and you would use the GPU for the PC2, and then generally leaving PC1 on its own. So you could kind of share the same server for these two things. But currently, I don't think we're. It might work, it might not. but at least it is a way to do it, but not the way that I have done so far. And then for this setup here, you would have a separate CPU worker. Then the other clusters that I've been working on so far has been the smaller setup here, where you have a dedicated worker for each role. That's how I started. And that turned out to be a really good way of doing it in the early Lotus, because a lot of problems were, we were facing a lot of problems when we started Space Race. Basically, the scheduler having some bugs, which means that it, for some, it didn't not really work at all. I did not see much of that. And I believe that one of the reasons why I was not so harmed by these kind of bugs and things that need to be tweaked in Lotus was because keeping each of the jobs on a separate node, meaning that I got really good control over how the scheduler would assign jobs, because basically one job could only go to one worker, and when it was done, it would be ready for the next one, and not having multiple jobs running and having to fight about the resources. So I'm sure this has improved a lot in the later Lotuses. It's just, for the early days, this worked really good having just dedicated roles, and also having this flexibility that you could basically scale up and down for each of the resources. And I guess this makes more sense the larger you go. And if you go into data center size, then obviously you would have much more flexibility in how much resources you put at each of these workers. But for my minimal setup, this was actually what I was going with, and I was almost hitting about 1 gigabyte of pledge storage every day. So I got a bit over 10 terabytes in the Space Race run. But I actually did a couple of different miners just to try things out. But I'll just come back to that. So then we had the bits bigger setup here, and basically what I did was take I actually had a big server which I split in half, and having 2 different workers running, one on each CPU. So it had 1 terabyte of memory, and it has 2 CPUs. And basically, I just split it in half. But that was a pretty powerful setup for actually running also on Space Race. And then to match that, actually the PC2 is not that problematic if you have this this kind of setup here, because it is quite fast. It can actually, I think it can do a new sector every 25 minutes. So that would actually be all that you need. But then on the C2 side, that gets a little bit heavy again, because these one takes about an hour each. And then for the rest of the PC2, I did like a big rig, and actually it's a little bit oversized on some of the things, but it turned out to be a good idea, because some of the congestion that happens when you have to shut off the miner and start it up again and so on, that actually takes some time. So just to get back to that, I also showed this the last time, how to actually try to visualize what is actually going on now that we are mining in a smaller setup. So what I tried to do here is show what does it look like if you have a miner that can, where you have a PC1 worker that can do 6 sectors in parallel. So that would be one of those workers that I just showed with the 512 gigabyte memory. So, it's not small, it's quite big. But then again, this is just a setup to show what is the dynamics of this kind of a setup. And basically, the PC1 is running 6 sectors in parallel, but they are all pledged with that that hour between them. So I wouldn't sit over, just start up 6 pledge sectors at once, because what happens is that in the start you underestimate how much NVMe storage you actually need, and then in the end it might be too much. Another thing is with the memory, it might also be, if you do that, that it actually doesn't figure out that you actually So what I do instead is I actually have a pretty slow startup, but I only pledge 1 sector at a time. Right. So what happens is that when you do it like this, then you have in this setup a new sector every hour coming out of PC1. That's basically what happens. A sector comes in and a sector comes out every hour, meaning that I would have 1 hour to complete my PC2. Otherwise, I would get congestion. I would then have it sitting in wait seat, and wait seat is fine. I don't really care about that much about my time for packing and my time for wait seat, because what happens is that the data is sitting on my NVMe drives, which is fine as long as I have the capacity, but I'm not spending any compute resources, so I don't have to take them into account for sizing the compute power I need. But in this setup, basically, I have an hour to do every sector. So I have an hour to do the PC2. I don't care about wait seat, but then I have an hour again to do the C2. And as long as I can do that within an hour, I won't have congestion in this setup. And basically, I had this running just like this setup right here, the double setup of this, and it runs very, very nicely. As long as we're not updating Lotus or doing any of these stuff, the brand outtake and all these kind of things that will screw up everything. As long as we're just in a normal steady state, this is very, very stable. And actually what happens is it's so stable that if I just, set it to automatically just split the sector and I come back the day after, it is still going. So the variance between how long time it does take to process and seal each sector in each stage here is pretty predictable. And I haven't seen that much variance. So that's pretty cool, because it means that if you get into this kind of scale, then it can actually run pretty good without that much maintenance, unless something breaks, of course. Right. So what I wanted to go into is basically just go through some of the kind of, I could call them like archetypes of workers. Because the thing is that you can't just say that one worker would be the perfect setup, because it really depends on how deep your pockets are, how much you want to invest, and also some people have hardware lying around, meaning that might size some of it, and then you need to make the rest fit, and then in general, this can just look different depending on how you want it to look. But I've seen these kind of different setups here. I haven't tried the high one, so that's why it's grayed out again. But that would be like a pretty strong single CPU PC1 worker. And again, this is thought out of the idea of having them individual, so not combined, which you of course could do, but then you need to kind of also combine these numbers here. But the thing is that this is thought out of a setup where you are using a fast network. So you have a 10 gig network between the nodes. So you would have dedicated workers for doing PC1. And what is stated here is that you can have this small worker, which basically what I have right now running, just here starting mainnet. And basically what you want is you want some kind of CPU, which is definitely an AMD for this one. So far, we will have Intel joining the party, but it will be with the Ice Lake, I think it's called. And so far, it's only mobile processors. And I think we will have to wait a bit for the Ice Lake SP, which is a Xeon version. But sometime we will be here with the Gen 4 PC Express as well. But it is pretty slow. But that specific version of Intel Xeon CPUs will also have the SAR instructions, which is specifically needed for this process as it is today. Because another point that I want to make is that although that I might come up with these archetypes now, it is really important that you try to keep it flexible and not, make each worker so individual and so customized that it will never, be able to reconfigure, because we don't know in a couple of months if we will be using GPUs for all processors. Could be. So basically, it would be pretty stupid to make something where you need to go and buy new hardware when things change. So that's one thing to take into consideration. We'll just get back to that. But this was just to say that you can have different sizes. Another point that I want to make about this is I have been doing most of Space Race and also starting mainnet here on consumer NVMe drives. And I just had this funny calculation where I actually figured out how much data is flowing, because I can see that in my network traffic, but I can also just use those normal metrics for how big are the unsealed blocks that need to move between PC1 and PC2. And I figured out that my poor normal consumer NVMe drives were doing just like 2.5 drive writes per day, 2.5. So they are technically engineered to be able to handle about half a drive write. So basically what it means is if you have a 2 terabyte NVMe, it is designed to write about 1 terabyte a day. And I was using it a bit more like 5 terabytes a day. So you could argue that I might be burning these disks down, and that's why we make these jokes about that it smells like burned NVMe and so on. So far I haven't broken anything, but I'm pretty sure that they are in pretty bad shape compared to when I started. And the point I want to make is basically if you want to make a miner that needs to be ongoing sealing for years, I think these consumer NVMe's, they will burn in the end. So what you need is basically, you have to pay, because enterprise NVMe's are way more expensive, but also they do provide this kind of setup that you need, where they can actually handle this workload without dying on you in the next couple of months or half year at least. Yeah. So that was just for the PC1. We kind of have the same on the PC2. What is different here is that if you have a dedicated PC2 worker, you actually don't need that much memory, because in itself, it's not really a memory consuming process. You can also do with more or less cores, where on PC1, you need to go with a higher clock frequency. I don't think it's that needed here in PC2, because PC2 is in general pretty hard on the GPU. And you will see that by if you have a dedicated PC2 worker that only does that, and it does it all the time, you have a pretty hot GPU, because it is hammered all the time. But that's pretty good, because it means that your computer might not have to be that, the rest of it doesn't have to be that hard. What does need to be there is, it is the same with the NVMe's, because as you have NVMe's in the PC1, which need to create these kind of large size sectors, they need to be transferred to PC2 before they can be processed there. And for that, you need the network. You can't do 1 gig. You need the 10 gig for that. But you also need an NVMe in the other end that can actually, get that data in. Yeah. But the thing is that you will also see here that these kind of setups using a 2070 Super or a 2080 Ti, they can actually handle quite a lot. They are pretty fast, so most of these are, can actually handle a pretty big workload. But we've also seen that if you do go into some of the older, like 1080s, not Ti, but the 8 gigabyte versions, it can start to slow a lot. So I had one older machine with an 1080 that was more like 1 hour and 15 minutes to do a PC2. So these cards are really good at it. Another point I could make here is that we have some very lucky people experiencing with the 3000 series. And I think the problem there is that basically when you do the Bellman that operation, it needs to be optimized for the GPU. And now the 3000 series comes in with a new CUDA count, which is awesomely high, and a new count of memory. And there is this calculation when you give it how many CUDA cores that you have, then it tries to, figure out what is the best setup. But currently, I think there's a lot more juice in those GPUs that is currently not being used, because probably that needs to be also optimized again. So it seems like right now the 2080 Ti is probably the most optimized card for doing these processes. So it's still a good choice, and the other ones will probably be better in the future. But right now we don't really see it that much. So on the C2, basically you also like a lot of cores here, because some of the C2 process is also a lot of CPU intense actually. So that's good. A thing that I didn't say with the PC2 and the C2 is that you can actually use Intel CPUs on this, and it works fine. So I have an Intel worker right now doing PC2, and it does it, the PC2, in also these 22-25 minutes, so no difference at all. But then again, you know, if you are talking about high core counts, then you will be talking about Xeons. That's really nice if you already have them. But I experienced that it works better on the gold and on the gold scalable versions. I also have some older, like 2680 V4s, and although that it is a V4, you should think that it's like fairly new, but it seems to be pretty lame. And also it's using a lot of power, so it's kind of running on all the cores and spending all the power it can do, but it's still slow. So I don't think it's really, you know, if you're going to buy new hardware, then buy probably new instead of buying that kind of old stuff. Hardware. But it is important to say that that the Xeons does the job just as fine on these workers, not on PC1. Yeah, so that's pretty much it. The differences I just pointed out here is that while I was able to do a pretty good time on the 2070 Super on PC2, then actually here the difference between these GPUs is pretty significant in C2. So I would say for C2 specifically, it's a pretty good idea to have a strong CPU or GPU. Sorry. Another thing that we are also seeing is that a pretty big EPIC CPU can actually also do the whole C2 in 1 hour and 45 minutes, I think it was. So if you're looking at this over here with the 2070 Super, actually it's about just as slow as if you just had the EPIC CPU actually doing the C2. So that's interesting if you're not going into having you know, expensive GPUs and doing it really fast. So that's another thing. But you see over here, when going back to PC2, that the difference between these two GPUs when doing PC2 is actually not that different, and probably both could work for having a pretty big setup. So what I did was basically I had one of each. So one of each of these, and in general, they are in average about half an hour if you combine them. So I was able to reach about a sector every 15 minutes on this setup here, combining these two. Yeah, so that was basically what I wanted to talk about, what is interesting on these parts. I also have some things here on the miner. Now, the miner in itself is much more difficult because the workers, you know, doesn't need to be very secure, high available, and all that kind of stuff. Because the worst thing that can happen if a worker breaks down or the NVMe drives burn and so on is that you lose the sectors that it's currently working on, which is like not a big deal, and probably if you even have more workers, then you can reorganize them into keep on sealing. So it's not the biggest problem, but the miner is a much bigger issue. And the thing is that, you know, I'm not gonna say that you should do it in one way or the other, because in the end, you know, if your miner breaks and you lose your I don't know, you kind of your metadata and so on, and can't restore your sectors, then you are like super screwed. So, you know, how to set this up in the best way is it depends on how much money you got and how much risk you're willing to take, I guess. So having a single rig to do everything and not having any RAID or anything, that is maybe the more like a cowboy style. And as long as it's making money and you get some of it out, it's good. But, you know, if you lose it all, then that's just it. But for these setups, I basically just try to say that, you can put it into to 3 different types. You have the ones which use GPU, like I do. So basically, you rely on having a pretty strong GPU to do the window post, which would be the proving sectors, and making sure that you keep your power, your storage power, and also the winning post, which would be when you get enough power to mine blocks, that you're actually fast enough to provide that winning post to actually be eligible for a block reward. So that's also an important part. But what I learned, not by my own experience, but what I learned from the last month, is that you also have the opportunity, if you have a pretty large CPU rig, you're actually able to run this without GPU, and you're also able to mine blocks. But the general thing here is that it probably needs to have a lot of cores, because if you are getting a lot of utilization by the daemon and so on, then you might have issues on actually making your window and your winning post in time. So that's really important. Another thing that I put in here is that in general, your OS data and so on probably should be on a RAID 1. You probably also need to do the backup, which is also a new feature that you can do of your data store. So just to keep that safe, keep your wallet safe and so on. But at least you need a RAID 1 so you can continue working. But then again, if you have a small rig, it could actually be okay to just have backup, and then if it breaks down, just rebuild it. So we have seen we have seen small miners actually moving their setup from one computer to another. So it is totally doable. So basically, you could back up things, and then if it crashes hard, then rebuild and get on it again. But in general, I think that it would be a good idea to have a RAID 1 to keep that up if one drive breaks down. And then in general, on the data disk, I have so far been using RAID 6, and I haven't seen much problems with it. So I would generally say that if you have like small setups and want to make this work without too much trouble, then it might be a good idea to not make those RAIDs too big. So one of the things that we see is that if you have like using the new 18 terabyte disks, well, do you know how many hours it takes to actually initialize an 18 terabyte disk when it can only read and write with 200 megabytes per second? Well, that's 1.5 days. So if you need to rebuild a RAID 6 that has a broken disk, it's 1.5 days. So that can be a problem for you if you get too large. Another thing is that don't put too many disks in. So my RAIDs is generally 12 disks each, but I would rather have many RAIDs. And then, if one breaks totally to crap, then, I still have a lot of power, but this area I might not be able to recover. I might need to do a backup or something like that. But that's in general there. So one thing that I have been, another pointer here is that in general, I have been using the app piece. So when you pledge a new sector, I have only had that running on my PC1 worker. In the start, and I don't think it's like that now, but in the start, if I also had that enabled, like app piece was true on my other workers, then you could get an app piece job that went to a C2 worker that already had 2 C2 jobs. So basically, it wouldn't pledge or start the process of a PC1 before after like 2 hours. So that would be pretty stupid. I think that changed now, but still, I normally just use my PC1 worker to do the app piece, and it takes a little bit longer. But again, I don't care about that time because that doesn't really, go into the bigger resource calculation. And the other thing that I will generally stress here is that, when you look into this slides, and you might go back and see them afterwards, remember that although that they are each specified a little bit different, then you might be able to use the same computer for each of this. So think about maybe having the same motherboard or the same server as base, And then, you know, some of them you don't put that much memory in. Some of them you put a little bit stronger CPU in. Some of them has a weaker one. But in general, if you keep the platform the same, then, you know, when we go a couple of months from now and from the Lotus team come up with something totally cool, or we change the algorithm, something like that, you know, you are still able to rebalance and flex the system and not locked into that, you know, I just built this on a Ryzen, which can have only 128 gigabytes of memory, and now I have no processor that I can run on there. So that would be my recommendation at least. Not saying that you should, you know, get rid of it if you already have it. Just if you buy new stuff, then might think about having, you know, a bigger set, just having this idea about that you could, you know, change everything if you'd like to. Yeah, so that's about it. So from here on, I have some pictures of what it looks like today in my basement. I know that I got a lot of comments on this last time, so that was a lot of fun. But the general idea is that you know, it's not enough for me to be a little bit idealistic about Filecoin. I also think that this should, you know, not be a total waste of energy. So what I do is basically have my my workers and my miner hooked up to my my floor heating. So what I do is basically what you see here is the back of these two rooms. So that's basically where I have my miner and my worker and my storage. And what I do is basically just have everything water cooled, which is like basic computer cooling. But the trick I do is then I send it up to the boxes up here, which is heat exchangers. And heat exchangers basically goes on to my floor heating, which is kind of dirty water. But I kind of keep it separate, so you have that that really cool green fluid that you can see. But anyway, it is clean. And you heat exchange the heat from all the GPU, CPU, and so on up into my floor heating. And the good thing about my floor heating is that it's kind of an endless way of getting the energy out, because I haven't been able to pull it higher than 40 degrees Celsius so far. So it's like, you know, how much power I put in. It basically, you know, there is so much that needs to be heated for the water to be 40 degrees. So that works very well so far. So I think I have a little bit over 100 terabyte of accessible data for so far. But I also made it really upgradable. So what you see is, I don't know if you can see it, but actually I have like a quarter of my actually drive base populated at the moment. So there's a lot of space in here. Another thing that is pretty funny in this setup is I have these custom made. So I wanted something that, you know, would not fill up like a full big rack, because this is in my basement at least. But so what I did was I had these custom made these disk arrays. So they basically only can contain the front part, and they're only like 25 centimeters long, about 10 inches, and then nothing after that. Because what I do is basically I just take the power cables from my power supply on the miner and just drag them into powering the array. So I don't have additional power supplies. And also the SAS cables is just coming directly from the controllers, just using like a 1 meter SAS cables. And what that means is I can basically run this whole array on my single miner. And I'm not using redundant power supplies for this, but I'm also not using that because, you know, yes, it's nice and we use that on all the server hardware I work with, but for this purpose, it doesn't really matter that much. Of course, I don't like data corruption, but then again, you know, it is, you know, unlikely that it will be everything broken. Probably if it's writing a sector when it happens, then it's really bad. But apart from that, I think this is a pretty good way. And the cool thing about it is that, you know, running the miner without any workers on, I only have one power supply. So another thing that I set up since Space Race 1 was that I actually downgraded from the 56 gigabit switches that we normally use that on my high performance clusters, and I had something in spare, so I just use that for Space Race Run. But basically now I went back to the regular 10 gig and just use that. And in general, you know, that performs just as well. And it's not really a bottleneck. But I have this kind of combination of using normal RJ45 for some of it. And then I also use fiber for others. So basically all this is set up with fiber, but you know, whatever, it works pretty good. And I haven't seen much problem with the networking. You just need to make sure that you're using jumbo frames for that one. So that's MTU 9000. Otherwise, basically, you don't get the throughput. So I see the throughput about a gigabyte per second. That's pretty much around that. Yeah, and another comment that I was just making with this one is that when we did Space Race 1, I had this Intel mining setup where trying to see how much can I actually do on Intel. And I ended up with having everything else than PC1 working on Intel machines. So the only caveat about this is that on this rig, I did not get enough power to actually be able to win blocks. So I'm actually not sure if my Intel Xeon here would be able to do that. But then again, you know, it should also be a GPU job partly. So it might just work at least for synchronization of the chain and for doing all the window posts and so on. No problems at all. So basically, this is just to say that you can actually run this on pretty old hardware. And as you see here, I also got some pretty old stuff going on over here. And you see the memory is not even fast and so on. But still, you know, this is actually producing sectors. So, you know, if you have stuff like this lying around, it might be usable. The only thing is that probably you'll just see that, you know, the power consumption of these old, big, slow setups might not be that efficient. But I'm actually still using the Intel setup down here with the really small. It's only a 4-core CPU, and I've actually also been using that for C2, which really stresses it out. But it does the job. So it's like you can still use that. So it really depends on what you got already in stock. You can use a lot of different things, but it really comes back to the beginning with you know, having these kind of calculations where you're actually able to calculate. So how fast can I do PC1? So how fast do I need to produce my PC2 and C2 to make sure that I'm not doing any congestion, and also that I'm not oversizing my PC2 and C2. And if you go to the start of my presentation, you will actually see that the big setup I had for Space Race 2 was actually quite oversized on the C2 and the PC2, and that was actually just part of, you know, figuring out who of or what of these workers was you know, performing good and who wasn't. So that was too much resources in there. But you know, from the example that I gave with that timeline, that's a pretty solid and pretty strict setup of how to run it right now. And it also comes with that thing about that, you know, if we get this optimization with PC1 in a couple of weeks or earlier, then we might have a PC1 worker which now has double performance. So now basically that's why I keep my PC1 worker pretty small at the moment and do not have large amounts of memory, is because, you know, if that goes to double performance, then basically the rest of my setup now needs to be double until that has also been optimized. But these are kind of the rules as long as we go with these smaller setups. So I guess we are kind of coming to the end here, and I think we also almost out of time. This one is just saying the setup that I also showed in the Space Race 1. So you can actually do it fairly cheap. But again, you know, this does not have the enterprise NVMEs. But that's pretty much everything for me.